Today we're going to talk about ratios. We've talked about proportions, and we've said that they have an equal ratio between two quantities. But if we don't know what equivalent ratios are or how to find them, then that can be really hard to understand. So let's look at a homework sheet that I obviously made up, or maybe Mickey Mouse is in my class. But I use equivalent ratios to help me grade things. So looking at this student completed 8 out of 10 assignments. And I know that's equal to 80 out of 100 points. Now, I know this because every assignment's worth 10 points, but if I'm trying to figure out their grade, I know, okay, if I'm doing a grade that's out of 100 points, 10 times 10 is 100 points, so I can multiply 8 times 10 as well, and that gives me the grade. Let's say there were only 5 assignments. So in order for this student to also get an 80, 5 times 20 is 100, so I know that some number times 20 is 80. So I do 80 divided by 20, I get 4. So they would have to complete 4 assignments out of 5 to get an 80, or 8 assignments out of 10. So let's look at some other examples and try to figure out how many points they receive. So 3 out of 5 assignments into 100 points. Well, 5 times 20 is 100, so I do 3 times 20 and I get 60. Let's say 20 out of 25. 25 times 4 is 100, so I do 20 times 4 and I get an 80. They made an 80. Okay, 17 out of 20 assignments. So 20 times 5 is 100, and 17 times 5 is 85. So they made 85. Now here's something to think about when you're trying to figure out if a grading policy is fair or not. This student completed 3 out of 5 assignments. Looking at the small number of assignments, that's a good amount, but they only made a 60. You know, if they completed 3 out of 20, that would be a 15, which is a lot lower. So it's kind of important to think about how much we originally started with. And we can also see this visually. So if I look at the 3 out of 5 assignments, like here, that is equivalent to this much, right? It's the same length. So that's 1, 2, 3, 4, 5, 6 out of 10. It's equivalent to 3 out of 5 because 3 times 2 is 6, 5 times 2 is 10. Okay, if I want to shade in a ratio equivalent to 1/2, there's a couple of different ways I can do that. There's, this is 4 by 4. There's 16 total squares. So 1/2 would be 8. So that could be this way. That could be this way. Either one. And if I want to shade in a ratio equivalent to 2/3, okay, here's 3 rows, so I need 2 of those 3 rows. Or I can do like, okay, 2/3 out of, this is 12. So I need 8 shaded, and it can be any 8. It could have been 1, 2, 3, 4, 5, 6, 7, 8. Like, it doesn't have to be really nice and pretty. So because proportions have equivalent ratios, let's look at some proportional examples we've looked at to see this ratio equivalent. So like 1 times 1 is 1, 2 times 1 is 2, 25 times 1 is 25, 50 times 1 is 50, and 0 times 1 is 0. So we have the ratio equivalence of 1 over 1. For this one, 1 times 2 is 2, 2 times 2 is 4, 25 times 2 is 50, 50 times 2 is 100, 0 times 2 is 0. So we have the ratio of 2 to 1. If I try to look for that on the graph, take a moment and try yourself. If I look at these points, like here I go up 1 over 1, up 1 over 1, 1 over 1. That's the 1 over 1 we talked about. Or over here, from point to point, it's up 2 over 1, up 2 over 1, which is the same thing as right here. So this equivalent ratio, or the unit rate, is the slope of our graph. Okay? We can also write ratios in the following way. So if I have 25 students pass the test and 5 students fail the test, that would be like 5 out of 30 failed, or 25 over 30 passed. But if I want to look at a ratio in a different way, I can say for every 5 students who failed, 25 passed, or vice versa. I like to look at either one. This helps me know kind of majority-wise whether my class is passed or failed. This is good to look at the exact numbers compared to each other, so I can see a much larger number passed than failed. Okay, let's find some equivalent ratios to 25 to 5. So I can divide both of these by 5 and get 5 to 1, because I have this 1, that would be like my unit rate. And then I can multiply. So if I multiply both numbers by 2, I get 50 to 10. If I multiply both numbers by 3, I get 75 to 15, and so on and so forth. So I find these equivalent ratios by multiplying by the same number. Okay, so let's find some more equivalent ratios. Go ahead and take a minute and find some equivalent ratios for these 3. So here's some possible answers. For 6/10, I reduced it first, but you can have different combinations. And I can do the same thing with like 3 over 7. Multiplying the numerator and denominator by 2, I get 6 over 14. Multiplying the numerator and denominator by 3, I get 9 over 21. So on and so forth. So go ahead and find some equivalent ratios for a 4th and a 9th. All right. Again, these are just some possibilities, but you can have more. So let's take the ratio 2 to 3 and apply it to school. So let's say in a group of students, for every 2 freshmen, there are 3 sophomores. Does that mean that there are only 2 freshmen and 3 sophomores in the school? Of course not. So we can have different combinations of students by making equivalent ratios. So we could have, if I multiply both by 2, I could have 4 freshmen to 6 sophomores. If I multiply both by 10, I could have 20 freshmen to 30 sophomores. If I multiplied both by 5, I could have 10 freshmen to, I lost my train of thought, 15 sophomores, so on and so forth. So I mentioned unit rate, which we can use to help create equivalent ratios. So let's do that to fill in this table. So to get from 2 to 6, I multiply by 3. To get from 3 to 9, I multiply by 3. And if I need to, I can just do 6 divided by 2, 9 divided by 3 to get what those would be. And then I can do 10 times 3 is 30. Okay, well then I need to find what number times 3 is 45. So I can do the opposite, divide by 3, and I get 15. Okay, so let's look at this one. Here, to go from 6 to 3, I divide by 2. So 30 divided by 2 would give me 15. 40 divided by 2 would give me 20. And then I have to find a number divided by 2 that gives me 28. So I do the opposite. I multiply by 2 and I get 56. We can also use ratios to find, or this equivalent unit rate stuff, to find different parts of ratios. So if there's a ratio of 5 boys to 6 girls in a class, how many girls are there if there are 15 boys? So looking at this, 5 times 3 is 15, so I do 6 times 3 to find the number of girls, and that's 18 girls. Okay, Thomas can answer 3 questions in 10 minutes. How many questions can you answer in an hour? Well, an hour is 60 minutes. So we got how many questions in 60 minutes? 10 times 6 is 60. So I multiply 3 times 6 and I get 18 questions. Okay, Miss Henderson can grade 4 tests in 10 minutes. How many can she grade in 45? So this one's a little bit tricky because, 10 doesn't easily go into 45. So if I divide 45 by 10, I get 4.5. So I'm going to do 4.5 times 4, and I get 18. So Miss Henderson can grade 18 tests in 45 minutes. Sounds about right. Okay, just a few more questions. Now let's look at just some graphs, comparing graphs. Meteoroid Perseid 245 and asteroid X traveled through the solar system. Which one's traveling faster? So this is the same time. Asteroid X has traveled more distance in the same time. So asteroid X is traveling faster. And we can say it covers more distance in the same amount of time, but it also has a steeper slope. Okay, this gives me the price of different lengths of 2 types of rope. We have cotton and nylon, and it wants to know if we buy $1 of each kind of rope, which one would be longer. So let's say this is $1. It doesn't matter where we put our mark, but cotton is this long, but nylon is this long, so nylon will be longer. Pretty straightforward. Okay, now let's look at some tests. In test A, if you get 0 points on the test, you get 0 points towards your grade. If you get a 1 point credit on the test, you get 1 point towards your grade. If you get 50 points on your test, you get 50. So I got that ratio of 1 to 1. Now looking at test B, like if I take this point, if I get 40 points or 20 points on my test, I get 40 points towards my grade. So that's like 40 over 20, I get 2 points. So if I had to say which had greater point values, it would be test B. Okay, let's look at 2 people's runnings. Jennifer runs a 10-minute mile. Okay, 20 minutes for 2 miles, 30 minutes for 3 miles. If I look at Jane, how long it takes her to run 1 mile, it's 5 minutes. So, who runs the faster mile? Jennifer. So, I want you to stop and think for a minute. Why is learning ratios important? Not just for a grading project, but in general. Why would knowing equivalent ratios be helpful? What sort of real-world activities would I need to know equivalent ratios? Then, How could inequivalent ratios affect grading policies, either positively or negatively?